Hey everybody, I'm MS Farzan, and welcome back to this video series on learning C# and Unity for digital tabletop game development. In the previous video, we looked at declaring variables and determining what kind of data types they are. And in this video, we're going to look at including them in functions or methods and generally being able to do other operations with them, like adding numbers together and adding numbers with strings and just doing all kinds of fun stuff. We'll also do a thing which is really fun, which is creating our own functions or methods and using them to continue our adventure of logging to the console. I know this might seem a little bit tedious that we're just working with the console right now. We haven't really done any game development, but these are fundamental concepts that we'll need to be comfortable with in C# programming that will help us in the long run when we're working with Unity. Okay, so let's get started. You'll see here that we have declared an integer I, a string hello, and we're doing a bunch of stuff in the start method. You'll recall that we said that a method or a function, which I've been really using interchangeably, although there are some nuances to them, are ways of encapsulating specific functionality in our code that we want to reuse over and over again. But we really haven't created our own functions or been able to see any value in them just yet. We've been using the start and update methods, which are provided for us by Unity, but we could use our own functions and make them and reuse them over and over again in our code. So let's take let's look at an example of how to do that. And in the same way, we'll be able to look at things that we can do with our variables, so that not just these static things that we use once or maybe change once. We can actually do some computations on them and use them to improve the functionality of our games in the future. So underneath this void update, I'm going to say void new function. And in some languages, we'll have programming languages. You might remember that I talked about camel case versus snake case. Sometimes in some languages, if something is public, which means that everything in your game can use it, we will name a function or a variable with both uppercase letters if it has more than one word. So this word new function has new and also function capitalized. If it's a private variable or a private function, we will actually name it with a lowercase to start, just like that, so that we know that it is only usable within this script. It's not usable anywhere else in our, like I can't access it from other scripts in my game. So we're going to do that, use that convention here. Depending on where you look or what programming language you use, that might vary. It's not super important at this point, but it is something to be aware of. And within these curly braces, I want to do something. I want to say, let's say, int I equals 0, debug.log I. Great. So I've created functionality here that you'll recall from the previous video. I'm creating a scope here that means that this integer I is only accessible within this scope. It's not going to be, I can't use it elsewhere by just calling I. For example, and in fact, because we have declared this elsewhere, use this integer I, I'm going to delete this code just so I'm not continually using the same naming convention for my integers. That might get confusing for me later, which I'm like, which I is where, or how do I use this I? I could just call this, integer J, for example. But for our purposes here, I'm going to keep this as I, and I'm going to delete I from elsewhere. So I'm going to delete int I and string hello. And when I hit save, I get all these squiggly lines because it's like, well, the compiler or the Visual Studio is like, wait, I don't know what I is. You haven't told me what it is. And because I've declared it in a different function here that has its own private scope, the start method and the update method are not able to determine what I'm asking for here. So let me just delete all this code. You don't need it right now. What I do have is this new function, and we're calling it void, where we say that it's void beforehand because it doesn't return anything. We don't need to talk about that right now. Just know that you have to write void before new function. And within the curly braces of that new function, we're declaring int I equals 0, and we're logging to the debug console the value of I. If we tried to play this right now, nothing would happen because we're not calling new function anywhere. We're not saying, hey, Unity, do this new function. So in the start method, we're going to say call new function. And the way that we, I misspelled it here, the way that we call a function, or the way that we say, hey, I want to use this function, is just by naming it and then putting these parentheses right after it. That just means this function does not take any arguments. I don't need to feed you any information about this new function. Let's create below this a void newer function. And notice that I've not only have I named the newer function something different from new function, but I've included the parentheses here. And here I'm going to say int I equals 5 debug.log I. So I've declared a new integer, also known as I, and I've made it equal to 5. And what I'm doing here is I want you to see that the scope of these two different functions are discrete. So although I'm calling an integer I here equal to 5 and another one here equal to 0, both are possible. Doing so is possible because the scope is local to these curly braces. I probably still want to do the same thing and call this, as we mentioned before, I'm going to call this int j, just so my mind remembers that this is a different I than elsewhere. But just for right now, I want you to be able to see that the scope of these two different functions is discrete. And in the update function, I'm going to say new function, newer function. So that just means that when the game starts and the object is created, I want to be able to call this new function. But when update is called every frame, I want to call newer function. So I should see one instance of 0 and then a bunch of instances of 5. Save it, return to my scene, press play. And I do see that indeed. I see 0 and I see a bunch of 5s. Great, that just means it's working correctly. If I had a ton of code, a moderate amount of code so that it didn't get too messy, I could put it between these curly braces and then call that wherever I needed it. And that's a reusable piece of code. So like I could say new function here within the update method and hit play. And then I see not only is new function called once, 0, but it's also being called during the update method. I'm seeing thousands of logs of 0 and also thousands of logs of 5. That just tells me it's working right. Let's see if we can make a little bit more complexity here. Let's say that in new function, let me delete this from the update method. In new function, I see int I equals 0. Let me say that I should be equal to I plus 5. And in the newer function, I should be equal to I minus 5. Save it, press play, and we'll see that we have one log of 5 and a bunch of logs of 0. Well, that just means that we're doing math. We're saying int I, we started out being as 0 in new function. And then we say, okay, now let's change the value of I to I plus 5. So that means that it looked at, Unity was able to look at 0 and say that I'm going to add 5 to it. And then what I'm going to do after that is I'm going to log what's happened here, and we get 5. Whereas in newer function, we said int I equals 5, and then I should be I minus 5. So 5 minus 5 is 0. And that's why we see a bunch of examples of 0. That's just how it works. I could say I minus 5. I could say I times 5. In fact, let's just do that. I had I plus 5. I equals I minus 5. I equals I times 5. I equals I divided by 5. Let's see what happens when we run our program. And we see 0. 0 and 0. Well, if we trace back the math, we said I is equal to I plus 5, so that's 0 plus 5 is 0, minus 5 is 0. I plus 5 is 5, minus 5 is 0, times 5 times 0 is 0, and 0 divided by 0 is also 0. So that's why we get 0. But if we wanted to do a little bit of shorthand, and we just say like I plus plus, for example, we'll check out what happens here. We get 1. Well, what happened here? Well, we said we declared an integer I, which is equal to 0. When we say I plus plus, that's called the increment operator, which means that I just want to add 1 to I. And if I say I minus minus, that's the decrement operator, which just means I want to decrease I. That's just a helpful little shortcut that you can use. So if we wanted to do this every frame, we would say int I equals 5, and then instead of I equals I minus 5, we could just say I minus minus, and then debug log I. And we're actually going to run into a quirk of programming, which will be excellent for us to learn from. And so I see I begins as 1 in terms of this scope in new function, and because we declared I equal to 0, and then we said I plus plus, that means that we're just adding 1 to I. And we log it, but then in newer function we say I is equal to 5, and I should be decremented by 1 every frame. So but we only see one example of that. We see I is equal to 4. Well, how come it isn't 3 and then 2 and then 1 if it's happening every frame? Well, that's just because in every frame we're assigning I to be equal to 5, and then we're decrementing I. So all we need to do here is remove this line that says I equals 5 and put it elsewhere in our script. I'm just going to put it, it can go anywhere, but it really needs to go at a higher level of scope than this function here. And I'm saying int I equals 5. And now when I hit play, I see that it's quickly decrementing I by 1 every frame. And I'm going to stop this because it's going crazy. I see it's already reached to 1273, but negative 1273. All that means is that I've started I from being 5 at the top of our script, and I'm decrementing it every frame with I minus minus, and then logging the value of I, which is really fun. And then it's working. And you'll notice that I'm still able to declare this integer I with a new function and incrementing it to just be 1, which is what we see at the very beginning of the game. because it's of a different scope. It has a discrete scope within its own curly braces than this other integer, but it's starting to get confusing. So what I might do is just call this int j and then j++. And then now at least I know that when I'm talking about the scope of this function, it's different from what else is going on in my scene. So great. That's we'll actually use this a little bit later. Just want you to get familiar with the increment and decrement operators so that we can use them later in our code. Great. Let's delete newer function, and we won't be using it right now. And let's just keep our new function and use it to actually do some fun things with adding numbers together, adding numbers to strings, and generally just getting familiar with how to use functions in our code. So let's delete int I equals 5 up here and start from scratch within our new function. And let's say that new function takes an integer called I. That just means when I put something between our parentheses here, that's called an argument. Similar to the way that we, if you recall, when we first started logging to the console hello world as a string, we were what's called passing in an argument to this function, which says to the function, here's what you need to do the work that you need to do. And so we're saying in this new function, we're saying that whenever we call this function, it's going to require an argument that is of a data type integer, and we're just calling it I for the sake of the way that we're going to use it in our code. It's also called a parameter. It takes a certain parameter, which is called I. We're going to say I equals I plus 5. And then debug log I. When I call new function, you'll see that it has a squiggly line here in my start method. And it says there is no argument given that corresponds to the required formal parameter I of debug script.new function. That just means that I have said that it takes I as a parameter is really the way to think of it here in the function, but I haven't supplied it any arguments here when I call the function. It's expecting me to call an integer. So let me just call new function 1. And if I refer to my the declaration of the function, I say, okay, this is a new function that takes an integer I as a parameter. And what new function should do, it should change I by adding 5 to it, and then debug log, or log to the debug console, the new value of I. So whenever I call this function, it has to take an integer, and we're calling it I here as a parameter. Now, in the start method, we're calling new function, feeding to it an argument, what goes in between the between the parentheses, and we're just saying let it be 1. And then let's call it again, and we'll call new function 2. So what it should do here is it should take 1 and 2, it should feed it, run it through basically a very simple algorithm, adding 5 to them, and then logging to the console their new values. So it should be, we should see, 1 plus 5 is 6, and then 2 plus 5 is 7. So those are the numbers we should see in our console. We hit play, and so we see 6 and 7. That just means that we've successfully fed this function 2 different numbers and logged them to the console, which is great. Let's see if we want to do a little bit more some more interesting things here, we could say debug.log your number is plus I. So we're using the debug log function or method, and we're feeding it two argument. Essentially one parent argument that is called, we have a string plus an integer, and we're saying your number is colon and then a space within quotation marks plus whatever I is equal to. We hit save and hit play, and we see your number is 6. Your number is 7. What we've done here is we've added a string to an integer, and we've put a little space in here because if we didn't do that, we would have your number is colon I, and there wouldn't be a space in between them. And Unity is able to understand that we want to have essentially two arguments here that says your number is, which is a string, and an integer, and just display them to the console. And one of these things is going to be static. We're never going to change your number is, but we are going to change this integer I. So we're not just saying your number is 5. We're saying your number is plus whatever this variable is equal to at this point in time when I'm asking you, Unity, to log it to the console. And so we see your number is 6 and your number is 7. So we could, for example, say, let's call string number is equal to your number is, and instead of writing that out here, we could say number plus I. In fact, let's call this number string just so we remember that it's a string. Number string. And we hit play. We see the same functionality here. That just means that, you know, when you, if I had a string that could be variable, like let's say I'm saying your name is plus, and then it's dependent on the user's name when they start playing my game. The string might be a variable itself. It's not something static that we want to print that every time to the screen every time. So we could store that string into a variable, and if that changes, then we just want the console to log whatever the string is at that point in time, plus whatever the integer is at that point in time. And that's the way we're able to have variable types of functionality. And speaking of variable types of functionality, well, let's say that we want a void newer function, and it takes int j and a string new string. That just says that this newer function, it takes actually two parameters. One is an integer called j and a string, which is called new string. And we're going to say j++ and new string. Actually, let's just log it to the console. Debug.log new string plus j. That just says that in this with this function, we actually don't know what new string is. We just want you to log it to the console. We're going to tell you it's at another point in time what new string is. You actually don't know what j is. And by you, I mean newer function. You don't know what j is, and you don't know what new string is at compile time or when we create the script. You're going to know it at runtime when we actually play the script. And what I want you to do is take whatever J is, add to it, and then log it to the console with whatever I told you new string should be. So in my start method, for example, I'm going to say newer function, and let's just start J as equal to 1 as the argument that the newer function will take. And we'll say your new number is space. So we're feeding to newer function the arguments 1 as its integer, and your new number is as its new string. And what it should do, it should add 1 to J, and it should log to the console this new string that we're feeding it, plus the new version of J, which is in this case would be 2. And we'll say newer function two, comma, your newest number is and then a space. Let's run this. And so we see your number is 6, your number is 7, your new number is 2, your newest number is 3. Let's take a look at how that works. We're calling new function twice, and we're feeding it two arguments, different arguments, which are passing it two arguments, which is 1 and 2. You'll recall that new function takes a one parameter, which is integer I, and when it receives that integer I, it does a tiny bit of math to it, and it says it declares a new private string called number string, and it says your number is, and then it logs to the console this new number string plus this new version of I, which is why we see your number is 6 and 7. But then it calls newer function and passes it two different arguments, which is 1 and your new number is, and 2 and your newest number is. And newer function takes two parameters, which is an integer called J and a string called new string. And it doesn't know what those are at compile time. It receives them at runtime when the game actually runs. It adds 1 to J and it logs to the debugger or to the console new string plus J. This is sometimes called dependency injection, which is not a term that you really need to worry about right now. It might be worth looking up, but it just means that this function doesn't know anything other than what it's supposed to receive, and it does work on it, and it's just a way of me being able to separate things and compartmentalize things in my code. So new string could and J could be something totally different, and this function isn't dependent on it when we are doing our work. I can do a bunch of work external to this, and then external to this function, and this function doesn't need to worry about it and is not dependent on it. We inject its dependencies at runtime, and that's why we get, when we play the game, your new number is 2, your new number is 3. Your newest number is 3. And so that's how to work with our own functions, and we did a little bit of math, and we added strings and integers together. In the next video, we'll look at how to compare different values and determine our game logic based on those values. It's also called conditional logic. And we'll look at how to run what are called loops so that we can do things over and over again if we need to. Thanks so much for watching this video. I hope that it's helpful for you. If it is, please like it and subscribe to my channel for more. I'd also love it for you to check out my games and books at entromancy.com or nightpathpub.com/entromancy, and even better, share them with someone else and let them know about it, as I'd love to get the word out about entromancy and my other games and novels. And we'll see you again in the next video.